All right, y'all. Hope everyone's doing well. First of all, go ahead and like and subscribe. I am now at 50 subscribers. Man, I'm getting popular here. I'm trying to work my way to 100. So if you haven't subscribed to my channel, go ahead and do that. But yeah, anyways. All right, it's a Friday. I'm excited for the 3-day weekend. Anyways, so let's go ahead and talk about what we're going to do today. So we are now going to go from the graphs to the equations for sine and cosine. So before we were given an equation and we were supposed to graph that particular equation. Now we're going the other way around. Now it turns out if you are given a particular graph, there is actually an infinite number of ways to write this particular equation. Okay, in order to kind of demonstrate that, let's look at this picture right here. Okay, so if you look at this picture, the red graph is graphing sine. Okay, the red graph is graphing sine, and then the green graph is graphing cosine. Now, if you look at it, they're essentially the same shape, just one is shifted over. So, for example, if I were to take this cosine and shift it, it's going to end up matching with that particular sine graph. With that logic, that's what gives us the whole infinite writing of equations thing from the picture. Okay, so, and to clarify that, right? So this one is my cosine. If I were to write a sine graph with a phase shift, it would be the same one, right? So they end up overlapping. It's just one is shifted over, or you can even think about it being shifted left. So there's multiple different ways to get an equation from a graph, right? And let's go ahead and demonstrate that with examples. Okay, so let's go ahead and do it. So number one. All right, and using your booklet, okay, or the notes here, this is the page we want to focus on, writing a sinusoidal function, and then, has basically the steps all laid out. So I will kind of follow these steps along as we go, especially on the beginning ones. All right, so number one, draw a horizontal axis of the transformed function. The vertical shift from the x-axis is d. Now, let me go ahead and say this. This axis that is being referred to here, that's what I've been kind of calling the baseline. Okay, I've been referring to it as a baseline. So that's the same thing, all right? In these particular notes, it refers to it as axis. So axis, baseline, however you want to think about it. All right, so let's go ahead and do that. Draw the horizontal axis of the transformed function. So that axis, right, if we're looking at my max and min, right, and there's a bunch of different places where that would be, we would look at it and see that this is, this is a 4, this is a -2, so we're going halfway. So my axis here is this right here. Okay, and you should have, an equal part on top and an equal part on bottom. So that is going to be your D value. So I'm just going to go ahead and write that, right? Any piece of information that I have that can be helpful, it's important to write it down as opposed to trying to do it all in your head. All right, so that would be step one there. Number two, measure the distance between the axis of the transformed function and the maximum value. This is your A. All right, so here's my axis. Okay, here's my axis. And there it is. Okay, that is my amplitude, right? The amplitude is always that distance. It's basically, two different ways to think about it. One is it's halfway between the distance from the max and the min. Okay, right? The max and min distance would be 6. But just this right here is another way to think about it. So my amplitude is 3. Okay? Determine the trig function, sine or cosine. So it actually gives you an option. You can actually pick here. I'm going to go ahead and pick cosine on this particular one. Really no real reason. I'm going with cosine. Okay? And cosine, as a reminder, kind of starts just the parent function. Okay, as a reminder, at 0 on the parent function, it starts at that +1. So it starts at that maximum point, okay, and that's what we're going to kind of go with. That's why on this one I'm going to pick cosine to go with, because it makes sense for me to just start at that point right there, okay. Personally, what I like to do is, so here's my y-axis. I just start to go over and see what's first. Okay, well, right there, my max is first. I would have to continue all the way this way to really have that beginning point there, okay? But anyways, so I'm going to start that max, all right? So I'm personally picking cosine on this one. But again, there's so many options to write these different equations. There's literally an infinite number of ways you could write it. Okay, so I'm going to go ahead and do cosine on this particular one. So cosine, draw the vertical beginning and ending of one period. So the beginning, right, was what we were talking about with the cosine. Cosine begins here. Okay, so I'm going to literally draw a vertical line there. All right, that's the beginning. This is the end. So notice, right, that same point and that same point, right? After this, it repeats. Cool? All right. Draw a vertical beginning and ending of one period. Got it. The beginning value is C. Okay, so beginning value, and now have a C value. Okay, so I'm going to write it down. 2 pi. All right. The transformed period is the transformed period also could be considered the new period. Okay, that's what we've been referring to as the new period as well. Okay, so that's the same thing there. Is the ending value, okay, minus the beginning value. All right, so calculate your B from there. You're going to take 2 pi and get the transform period. That's what the whole thing would be equal to. Now, another way I would do this is, me personally, I'm just going to go ahead and write my new period is equal to 2 pi over B. Okay, 2 different ways to think about it, right? You're using the same kind of relationship here, but me personally, I like to write my new period. I like to go with one equation, and this is the equation we already learned, right? The new period is equal to 2 pi over B. All right. So where were we? We should get the new period here, okay? And one way that you could do this, right? It does say to do the ending value minus the beginning value, but you could also just measure, right? So like, I mean, look at it, right? It's starting at 2 pi and it's going all the way to 4 pi. So your new period is 4 pi. Okay, but don't forget that your new period is. So that's what it's equal to, but it's also equal to 2 pi over B. Okay? So careful there, right? The new period is 4 pi. That's literally what it is, but it's also equal to 2 pi over your B value. So this would get you a B value of 1/2, right? 2 pi divided by 1/2 is going to get you out 4 pi. So you now have your B value. Okay? So we actually have all 4 of our values, A, C, D, and B. Okay? Why I went out of order, I don't know. Anyways, so cosine, let's go ahead and do it. Right, your A value is right out front, so 3 times cosine. All right, B value is next. We're going to go ahead and write the 1/2. Got to make sure that, well, you can put parentheses there if you want, but got to make sure you have parentheses here, right? Let's go with theta. Let's go with theta, not x. Probably better use theta. All right, so theta here, and minus your C value, right? That's your C value there, and then plus 1. That is your graph right there. That is one example, okay? And let me say again, you might do this particular question in a different way. There are an infinite number of ways that you could get any, like you can write an infinite number of equations from this graph. Okay, some people, I'm going to go ahead and throw it out there, I'll just give you a few options. Some people might even choose to put a negative out front and start it here. Negative cosine, that's also an option, right? Because it kind of looks like that flipped, right? Like it starts in the very beginning as a flipped, right? So you could, in other words, you could put a negative out front and change it if you wanted, and then you'd have to change up these values though. Okay, so your A, B, C, and D would change if you ended up putting a negative amplitude out front. All right, and that is it. And just to show you, right, just as a reminder, the form that we're writing it in is this right here. Okay, and you could do x or theta. Okay, it really doesn't matter either way. So, but A is out front, your B right before it with parentheses here. Got to make sure you have those parentheses, and then plus D is the last thing we will do on that. That's one example. Okay. So we did cosine this time. Let's go ahead and do sine this time. All right, but same process. All right, let's try to do this one maybe without the notes. Okay, you want to get that horizontal axis. So here we go. Here's that horizontal axis right there. That gives me a D value of -2. Right, it's how far it is from that x-axis. So I can right off the bat get my D value. Okay, next is essentially going to be getting the distance. Getting your A value, right? So we've got the axis here. Got my alarm. We've got the axis here, therefore your amplitude is going to be 2. All right, so axis to the top, 2. So we've got a d value of -2, a value of 2. Deciding between sine and cosine, I'm going to decide sine on this one. Okay, so sine might be best to start. Actually, I'm going to go ahead and do, just to make our lives easier, I'm going to go ahead and start this one as sine. Now, the reason is because the way that this this particular one starts. Okay, if you were to do cosine, you're going to have to like start it right there, and we don't know that value in between. It certainly looks like it's halfway between, but just to be safe, we're going to go ahead and start it here. Okay, so I'm actually going to choose cosine again on this one. We will definitely do sine next time. All right, so just keeping in my mind that we're going to do cosine. So I want to look at those max values, so that's where I want to start it. And then I'm continuing all the way, and it starts to repeat right here. So we've got to find that distance, okay? And based on these values, so because this value is 2 pi and that's 0, it's just going to be 2 pi. So my new period is 2 pi, which gives me a b value of 1. So I've got A, I've got B, and then the phase shift. Okay, so the phase shift is that starting value. So let's see what that particular one is going to be. Looks like we are counting by thirds here. Okay, so we've got 1 pi over 3 is that value. So my x value there is going to be negative pi over 3, which gives me my c value. Okay, so that's that c value in there. So now we basically have it all. All right, so we've got y equals 2 cosine. Right, 2 cosine. We've got a b value of 1, so we don't have to put anything for that. It's theta plus pi over 3. Got to be careful there, right? It's the opposite, right? It's the negative because that is shifted to the left. I need to have a plus there. And then minus 2. And once again, different ways to do that. But in my opinion, that's probably the easiest one just because it's, I don't know, that's just what kind of worked natural in my brain is to start it at that point and then to end it at this point. All right. But lots of different ways to correct this. Okay. But that's just the way I would suggest. Number 3. Definitely going to use sine here. And it makes it this problem kind of lends itself towards using sine. Because it starts, look where it starts, right? It starts at that baseline. So here's my baseline or the axis. Okay. And notice the axis is just on that x. The axis is on the x-axis, so we've got a d value right off the bat of 0. Next part of the process would be to find that amplitude. Well, here's my axis or my baseline, and I find that distance. That's one spot where it is. That's another spot where it is. So my a value is 1. Again, like I said, I'm going to choose to use sine here. Okay, let's find the period. The new period is going to be, and actually let's find our starting point. Technically by the order of everything, it does say to draw a vertical line at the beginning and the end. So I'm going to go ahead and start that one there and then end it here. So my c value is just going to be 0, right? I'm starting it at x is 0. So I've got everything but my b value and my new period here, right? This distance from here to here. It's hard to see here, but that value was pi. Okay, so it went from 0 to pi. Therefore, my new period is pi. But don't forget that formula is 2 pi over b. The new period is equal to 2 pi over b, all right, which gives me a b value of 2. All right, so I have b, I have d, I have a, I have c. But one thing I noticed about this graph is look where it starts. It's actually starting down, okay? So really, my a value is going to be -1, okay? So that's the one part we left out there is that my amplitude is -1 because it just starts down like that. Now, we could have started it here. Understand, we could have started it here, right, and gotten rid of that negative. Okay, but we would have had a different phase shift. I chose to go with the phase shift of 0, and that's why you're going to have to start this one off with a negative. All right, so here we go. Let's go ahead and write it. Y equals negative sine. Okay, next is my b value, so it's 2 parentheses, just x. I guess it's just, right, we have no phase shift, so I'll put it as theta. All right, and then also no d value. So that's actually it. Okay, y equals negative sine of 2 theta. Could you get a different answer from this? Absolutely. But that's one way to crack this one. And look, again, you didn't have to pick sine. You could have done that with cosine. You could have maybe started it here, right? That might lend itself to a pretty good solution as well, right? You could start it here. This would be your starting point. This would be your ending point, right? And you could have used cosine on this particular one. Lots of different ways to do it. And one thing I'll say is, right, make sure you ask, right? I mean, because your way of thinking about this could be very different than mine. Maybe this one, you're like, I want to use cosine. Perfectly cool with me, okay? But you've got to make sure, you know, that particular one does actually indeed work for the picture. All right, number 4. These are a little bit different, just some kind of thinking problems. So yeah, let's jump in. So it says sketch the graph of the sinusoid described. Sinusoid is just a fancy word for sine or cosine function. Write the particular equation after that. So sine curve with a period of pi, amplitude of 3, phase shift of pi over 6, vertical shift of -1. So these are all your different values, right? This is your C, your vertical shift is D, your amplitude is your A, and then remember your period is related to B, but it's not literally your B, okay? So the new period, this is what that's referring to, right? The new period. So let's go ahead and get the graph. Let's jump in. I'm going to not use this. All right. So here we go. Start at pi over 6. End at, well, what do we end at? Well, if my period is a length of pi, all right, so I'm going to be adding pi to pi over 6. But this pi here, right, I'm working with sixths. Zoom out a little bit. I'm working with 6, so I'll probably want my period in 6. So this is 6 pi over 6. So in other words, I'm adding to that pi over 6, I'm adding pi, which is 6 pi over 6. So this is going to be 7 pi over 6, right? I had pi over 6, I added 6 pi over 6, so I got 7 pi over 6. And back in. Okay, so I got my halfway, halfway, halfway. Halfway between this, all right? 6 pi over 6 is the length, so I'm adding 3 pi over 6 to this to get that. So adding 3 pi over 6, so that's going to be 4 pi over 6 here. And I'm going to leave it as sixths, but understand that that's 2 pi over 3. Okay? Definitely with these questions, if you kind of want to leave it as better fractions that work with you, go for it. Converting, sometimes I think converting is a little bit excessive if you ask me. There's nothing technically wrong with this. All right. Anyways, so from pi to 4 pi over 6, okay, we're adding 3 pi over 6 in between here. So you got to be careful. From here to here, we're adding 1.5 pi over 6. Okay, so this is like 2.5 pi over 6. In order to convert it, 5 pi over 12. Okay, be careful there. If you wanted to convert everything to twelfths, that could be a good strategy as well. 4 pi over 6 to 7 pi over 6, we're adding 3 pi over 6. So in other words, from here to here, we're adding 1.5 pi over 6. So that's 5.5 pi over 6, which is 11 pi over 12. All right, so we have our values there. The y is somewhere over there. Okay, there's my x-axis. Cool. And let's see, vertical shift. Let's get my axis there, my baseline. And I'm just going to put -1 right there. What is my amplitude? My amplitude is 3, so 1, 2. The scale here is going to be a little funky. Bear with me. Okay. But -1 to 0. Got a lot of space there, but whatever. Okay, and then -2, -3, down to -4, right? Because the axis, the baseline is -1, but it's an amplitude of 3, so it's going to be going up, up, 1, 2, 3, but also down 1, 2, 3 from that -1. This is a sine curve, all right? So it is starting at the baseline right there. And then it goes up, and then back down, and then remember it ends there, and then, oops, goes all the way up though. Amplitude of 3, right? I was applying an amplitude of 1 there, but 1, 2, 3, so it goes all the way up, and then all the way down here. So that, it's going to look a little bit disproportional, but it continues on forever, okay? But it is disproportional because of that funky space in between. I was just trying to save space with my, just because of those different x values, okay? There's that one. The only thing we need to add is the graph here. Let's back up. The graph. I have my D value, I have my C value, I have my A value. I don't have my B value, okay? But it's a new period of pi, and we know that new period is equal to 2 pi over B. Therefore, my B value would be 2, okay? B value of 2. So, one way to write this graph would be as follows. We've got y equals A of 3. So it's sine, all right, B value of 2. Okay, so 2. And then in parentheses, we've got your phase shift. So I'm going to use x since I didn't do that before. Pi over 6, x minus pi over 6, and then all minus 1. That is one way of writing that one. And last one, here we go. Okay, this is an interesting question here. All right, low point of pi over 2. Let's zoom in. Low point of pi over 2, comma 3. Next high point of 5 pi over 2, comma 5. Okay, so let's just sketch it. Let's just draw some curves here. And then let's try to extract some information. Low point. One example of a low point is pi over 2. Okay. Pi, that coordinate, pi over 2, comma, -3. The next high point, right there. Okay. 5 pi over 2, comma, 5. So let's see what pieces of information we can get from this. Okay. I think the easiest piece of information is going to be your D value and your B value here, right? And this is a good problem because it kind of really makes you think about what is going on, right? This is your max, this is your min. Okay, so the difference, right? The difference of your y's, right? It goes from -3 to 5, right? So there's a difference of 8 there, which means your amplitude is 4. Amplitude of 4. I've locked that part in. Okay, I've locked that part in for sure. All right. And let's see what else we can get from that. It also can get you your D value, right? It can also get you your D value. So you've got your amplitude, okay, and then your halfway point, right, is going, since it's a distance of 8, adding 4 to that -3 is going to get you 1. So you have a D value of 1. All right? Let's talk about what the period would be, okay? So if we went from pi over 2 to 5 pi over 2, just from the min to the max here, we're going to continue adding that, right? Like this is half of the period, what we just did, from pi over 2 to 5 pi over 2. All right, so we were adding 4 pi over 2, and then we continue. So it's adding 4 pi over 2 to get to 5 pi, and then adding another 4 pi over 2. So it's going to be 9 pi over 2 here. This coordinate is going to be 9 pi over 2, comma, -3, right? Because this is the same y value there. So this is your period length. It's going to be 8 pi over 2. Okay, so in other words, your new period we're just getting some information here. Your new period is going to be, it was 8 pi over 2, so 4 pi. Well, we know that the new period is equal to 2 pi over b. So what's your b value? Right, and this is just information. Your b value is 1/2. Right, because we were doing 2 pi divided by 1/2 gets you out that 4 pi. So we've got an A, we've got a B, we've got a D. Now we need our C. Okay, and that is a little bit different here, right? So a couple different ways to think about this one. All right, the way that I am personally going to do this is I'm starting off with a minimum here. Okay, so that's kind of, if we're thinking about it in terms of cosine, right? Cosine typically starts at a max. We're starting with a minimum, right? So I'm going to use that pi over 2 as my phase shift, all right? I'm going to go ahead and say my C value is pi over 2. But when I do that, what do I have to do with my amplitude? I've got to make it negative, right? We've got to make it negative because it's starting down low as opposed to starting up here. Okay, now, you could start it up here if you wanted. Okay, nothing wrong with that. But personally, that's the approach I'm taking on this one. But you could totally use this as your phase shift and then not do this whole negative thing. I'm just showing you one other way to do it. So now we have all the pieces. We determined it was a cosine graph. All right, so we have y equals -4 cosine. All right, b value is next, so 1/2 x. 1/2 x minus that pi over 2, which is here, your C value, and then plus 1. All right, so that is a solid problem there. And we essentially already have the sketch. I would consider that a sketch. But if we want the true values, right, really the only other value we need to find would be like here. That. So in order to get our x values. So if you wanted to get a more solid sketch, kind of like we've been doing, then yeah, you're going to end up just kind of, let's see, so adding 4, so that baseline there is your 1. So really your x-axis is here, somewhere in there. So you have that value, it's pi over 2. You just would need this halfway value in between here and here. Okay, so, but honestly, that is a perfectly fine sketch if you were to ask me. That's all I got. Hope you guys have a great day. Make sure you ask questions about this sine, cosine, graphing stuff. It's a lot, okay? It's a lot. There's a lot of different pieces, right? Amplitude, phase shift, all that stuff, right? Vertical shift. So just make sure that you are being diligent in understanding this material because it is a lot to handle, all right? But that's all I have. Hope you guys have a great day. I will see you later.